Hi, and welcome to another very exciting but also very important tutorial. Today we're going to talk about JSON, and this is something that you can see here. We're going to have a look at that in a second again. But before, we are going to have a look at what JSON really is and how we can use it in our applications, because many people have asked me how to use JSON with Swift, and if you do not know what JSON is, let me just give you a quick explanation. So first of all, JSON stands for JavaScript Object Notation, and it is a format that is great to exchange information from a web service, for example, between this web service and your application or different applications, because it's both very easily readable for humans and also for to work with in different programming languages. And what JSON really is actually a notation to combine different keys with different values. As you can see in this graphic here, we have a string, which is a key or a name that points to a specific value, and they are connected with this colon. And you can separate many of these key value pairs with comma. So this is just a format of JSON that is this JavaScript object notation. So in practice, JSON looks something like this. So you have these curly braces that wrap this JSON block, and within these curly braces, we have these different key value pairs. So for example, what we have here is a key names, which points to an array, or the value of this key is an array because these elements are written in brackets, just as we do it in Swift. And what we have here on the left is the JSON, or the pure JSON code, and on the right we have a tree interpretation of this code, which is a little bit nicer because we can also see the different elements of this array, for example. So we just have 3 elements with names with string values in this array. And we can also define different other types like booleans, numbers, and also again strings. So this is a very basic explanation of what JSON is. And if we have a look at a web API, for example, like the darksky API, which we can use for getting weather information, you can see that the example request here made with a HTTP request is pure JSON code that we can interpret and use in our application. And this is exactly what we are going to do. We are using the darksky API now to access a web API and to get information from that API and interpret that in a way so that we can use it in an iOS application. To work with darksky, what you have to do is log in, create an account, and get an API key, which is something like this here. It is completely free if you do not exceed a specific limit of API calls, but we won't reach that. So if you want to follow along, please use your own API key for that. So let's open up Xcode and get started. I'm going to choose a single view application here, just calling it JSON, creating it on my desktop, and we're going to start with creating a new Swift file here. I'm selecting my app delegate file so that it's going to be placed right below it, selecting a Swift file here from our templates, and I'm going to just call that weather and hit the create button. And the reason for that is because I do not really need to subclass anything, not even NS object. We can just create a struct for that. Let's just call it weather, and making some curly braces here to begin a code block. And since most apps follow the model view controller design pattern, it is useful to convert JSON data to objects that are specific to your app's domain in a model definition. So what we have in mind now is an app that provides search results for weather information, and we'll implement a weather model with an initializer that accepts a JSON object and a method later that makes an HTTP request to a web APIs or the darksky web APIs endpoint, and then asynchronously returning an array of weather objects. So let's start with the model, and we have 3 pieces of information that we want to display. First of all, a summary, which is a string, just giving us a description of the weather condition, like it's sunny all day or something like that. And we're going to have an icon, which is also a string that could be the same string that we use for some images that we can import to our application, like sunny or clear day, rainy or something like that. And then we're going to have a temperature double value. And this is just our data model that we are going to use. But how do we actually get these pieces of information? To understand that, let's have a quick look at our darksky API documentation, and there is this example request that looks for specific coordinates with a latitude and longitude. And as you can see, the result, the JSON result here, gives us that latitude and longitude again, a time zone, and the current weather for that specific location. We do not want to display the current weather, we want to get a weather forecast for the next few days. So if we scroll down, you can see that we have a minutely forecast, an hourly forecast, which we have here, and also a daily forecast. And there we already find a summary, but this is not the summary that we're going to use. Instead, we are going to use this data array. And we can tell that this is an array because there are these brackets. And if you remember our online JSON editor here, we had this names array, and this is indicated by these brackets. And if we have a look at the data array here, you can see that we have, or we can have, multiple items or dictionaries here again with key value pairs. And also there is the summary, the icon, and different temperatures like temperature max that we are going to use. We could also use apparent temperature max and so on. But this is the data that we really need. And I just mentioned dictionaries because dictionaries are what we get from a JSON file or a JSON format that we download from the web. So what we need to do is converting that into a dictionary. And a dictionary is also a simple collection type in Swift that has key value pairs, and we need an initializer that can take such a JSON object, and this is then of course a dictionary. We define that by using brackets, and then we specify the data type of our key, which is usually a string, and the data type of our value. Since we do not have always the same value, as you can see here for temperature max, we have a double or a number value, and for our summary we have a string. So to make sure that our application still works, we can just specify this as any so that we can receive different types. And we are building a type here conforming to the error protocol, and we implement our initializer, and we wanted to be able to throw an error of a specific serialization error type if something goes wrong, because the process of converting this JSON information into a dictionary is called serialization. And to be able to throw errors here in this initializer, we simply add the keyword throws here. And so that we know what we actually have or what kind of error types we have, we create a serialization error type that conforms to the error protocol. And we have two cases for our error here. One is, for example, missing. And we use a string here to give additional information. This could possibly be the case if we are looking for a specific key, but it's not there. And what we also could do is using invalid here with the string and any data type to indicate that something is not right, that data that we receive does not work. And so these are the different serialization errors that we might be dealing with. And in our initializer here, we now need to think about how we get this information from our JSON object. And if we imagine that the information that we have here is already converted into a dictionary, we can do just the following, which is quite simple actually. We use a guard statement here to be able to throw errors if something goes wrong, and we define a constant here for our summary, for example. And what we do is using the JSON object, and now with the brackets we access a specific key, which is summary in our case, because you remember here we have this dictionary here. This is what we want to receive in this initializer, and we want to convert it into our weather object, or we want to initialize a weather object with that. And here we have this key summary that we should be able to use. So this is the first step, and then we need to cast that to a string, since this is at the moment of type any. And if this does not work, what we can do is simply throw a serialization error of type missing, and we can say that summary is missing here, or something else. We could also say summary is not available in this dictionary, or whatever you like. So next up is going to be the, let's say, the icon. So again, JSON accessing the icon, and this time again converting it to a string. And if this does not work, we throw an error or a serialization error with a missing, let's say icon is missing. Okay, last step is going to be another guardlet for temperature. And this time we use again the JSON object accessing temperature max, and just to make no mistakes here, I'm copying temperature max. So here we go, and this is something that I'm going to cast to a double. And if it does not work, we throw a serialization error missing, make some more space here, and let's say temp is missing here. And now we have all these pieces of information from our JSON object, and the last step we need to take now is initialize our properties here. So first of all, let's say self.summary equals summary, self icon equals icon, and self temperature equals temperature, and then we can build that, and we should be good to go. Build succeeded. And now we have an initializer for our weather type. And we could also have built an optional initializer just returning nil if the serialization fails. But now we have done this with our serialization error type, and this is also just fine. Now what we need is a way to get the information we need from the darksky API. Therefore, we need a URL that we can access, and if we have a look at the darksky API, this is the URL that we have to use, api.darksky.net/forecast/your key, your API key, followed by a latitude and a longitude. And what we are going to do now is defining a base path for our API request. So I'm defining a static constant here, calling that base path, and simply pasting my API base API path here with my API key. And this is where you have to enter your API key for this to work. And now we also need a function that can get this information, this forecast information, and from where we call this function, we need to get an array of weather objects. So let's also define this function as static so that we do not need to create an object of our weather type to access this function, and I'm going to call it forecast with a location. And for simplicity's sake, I'm just using a string here, and if we were to use real locations, we might be using a CL location object here. And then we're defining a completion block here, and the completion is going to escape this closure, so we need to define escaping here without an E, at escaping, and what we want to escape is an array of weather objects, and we do not need to return anything here, so we are good to go and can define our function block. Let me just make some more space here, and then we can start defining our URL, and this is simply going to be the base path, and we are appending the location string, which will be simply a pair of coordinates. And then what we need to do is creating a request, a URL request. It's very simple and basic, so we have a URL request here, initializing it with a URL, so we're defining a URL object here with a string. The string is our URL here, which we just defined, combined of the base path and the location. Then we can directly unwrap this because we know that this should not be nil. And then we will define a data task also as a constant. This is going to be a data task using URL session, the shared session, and defining a data task with a specific request and a completion handler. So here we just pass along the request that we just defined, and then we have here a completion handler that gives us 3 parameters: a data object, a response object, and an error object. And we are just going to use the data object right here. And just that we do not forget this, what we should do with this data task is for it to start. So we can use our task object and just call the resume function on it after we have defined this closure. And now that we have our data task and we make our request, we need to do something with the data that we actually get from this request. And what we want is to return an array of weather objects in our completion handler. So we first of all define a forecast array, which is going to be of type weather array. So just a bunch of weather objects here, and I'm initializing it with an empty array. And then we can check with an if-let statement if we have a data object that we can work with. And this is going to be kind of the pyramid of doom that we're going to create here, because we need to check several times if things are working and if we can access or if we get the information that we really need. First of all, we need a do try catch block here. So I'm defining the do, and I'm defining the catch. And what we want to do is, again, using an if-let statement here to get a JSON object. And this is now the most interesting part if it comes to JSON, because what we want to do is try to use the JSON serialization class, which converts the JSON format or the JSON data that we receive from the API into a dictionary that we can use. And here we use the JSON object function with data. So this function can actually throw an error. This is why we use the do try catch statement here. And here we pass along our data object and an empty options dictionary. So with that, we still need to cast that to what we actually want. And what we want is a dictionary with string keys and any object values. And if this goes wrong, we need to catch the error. So we simply print the error and its localized description. And with that, we now have a JSON object. Here we still need some curly braces for the if-let statement for this check. So if this JSON serialization works and we get a JSON object as a dictionary here, we need to access the data that we want. And to do that, we should have a look at our result that we get from the API. So this is the dictionary that we now receive. And what we want to access now is, let's scroll down again, is the daily key first. So let's go back to Xcode and do that. And therefore, I'm again creating an if-let statement. And that's why we have the pyramid of doom here. So we have a daily forecasts array here, or a dictionary. And here we use now our JSON object, and we're using the key daily. And we're casting that again to a dictionary with string keys and any object values. And if we have a look back at the data that we receive, you can see that we indeed get a dictionary here. We can notice that by these curly braces. But what we want is this data array. So we need to get one step deeper or one level deeper. And therefore, again, an if-let statement. I'm going to call that daily data. And what I want to do is, using daily forecasts, access this dictionary and accessing the data array with the data key that we have here. And this data array now, which we can tell because of the brackets here, contains again a dictionary or multiple dictionaries, which we can tell by the curly braces. So what we need is an array of dictionaries. So again, back in Xcode here, we need to cast that into an array, so using brackets, of dictionaries, using brackets again, of type string and any. So we have the string type for the key and the any type for the value. And if that works again, and if we get this daily data, then we can iterate through this array. And if I correct this here, then we should also get rid of our error. What do we have here? So there is a equal sign where we need a question mark. And now let's just do that again. Okay, now we're good to go. So with this array here now, we can iterate through the different data points. So I'm using a for in loop here for a data point in my daily data array. I can now create a weather object. And since this can fail, or this can also throw errors, we need to, again, use an if let statement or a do try statement, but we are using an if let statement here now to directly unwrap this if it works. So we have a weather object now. Let me also call that weather object. And we are trying this with a question mark. So if it fails, we get nil, or this if let statement just does not work and we don't get an error. But what I want to do now is initialize a weather object with my data point. So this is going to be that. And now all that is missing now, and all that's left to do, is for us to append this weather object that we should now have to our forecast array. So I'm using the forecast array, and I am appending the weather object here. And let me just quickly build that. And the build succeeded, and now we are actually good to go. So to test that, we go into the view controller that was created for us when we chose the single view application template. And I'm just using view.load here. I can use the weather struct, the weather type, and use the forecast with location function right here. Now let me just copy a pair of coordinates really quickly. And then I'm pasting that here with my location. And this is our coordinate pair. And now for the completion handler, I simply press return here. I can call that results if I want. And then we can iterate through the results using a for in loop again for result in results. And let's print our elements that we received. So I'm using string interpolation here, using the result object, and then just two empty lines so that we can distinguish between the different objects. And now we can run this in the simulator and see if we can indeed get weather information from the darksky API that is structured just the way we want it, using our weather data model. And now we should get a nice result, which we did not get. So let's have a quick look at our weather type here, at our struct. And the problem is that we did not call this completion handler. So what I need to do here is right after my catch, I can actually call this completion handler and give it my forecast array as a parameter. And now we should really be good to go and see some interesting weather information for wherever this actually is, where I got the coordinates from, and indeed, there we are. So as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8 days of weather forecast with different summaries, different icons, different temperatures, and this is pretty cool already. And in the next tutorial, we are going to build a user interface for that. But for now, let's just recap what we know about JSON. So you have seen the structure of JSON, which is always key value pairs that we can access. You've seen how you can use or how you can distinguish between an array, which is always indicated by brackets, and dictionaries, which are indicated by these curly braces. And you have seen how you can go through such a response from a server and determine what information you actually want to process. We've also seen that it's quite useful to have your own data type when it comes to processing the information you get, to respect also the model view controller design pattern. And you've seen that for each web API, you might have to build a different structure in order to access the information that you really want and need. And what you've seen here with the initializer and the way to access or to serialize the JSON data, this is just done with Swift language features, so we did not use any external library to achieve that. And I think you can use this approach from many different APIs if you know what you need to look for in the information that you get from the web. So much for working with JSON and accessing a web API. I hope you're going to join me in the next video. I think this should also come out this week when we build a user interface around that. I thank you so much for watching, and I'll see you in the next one.